Chapter 1. Human Vision and Fiber Optic Endoscopy. 1.1. Human Vision. Let's begin. Looking at objects at different distances. Whether it is a camera or a human eye, we cannot focus a near object and a distant object clearly at the same time. Why? In junior science class, you have learned that a human eye has a lens, which can change its thickness, and hence its curvature. In fact, the focal length of a human eye increases with the object distance, as objects at different distances require different focal lengths of eye lens. A human eye cannot focus two objects at different distances at the same time. 1. The human eye. Light is refracted mainly by the cornea and then by the eye lens. A real and inverted image is formed on the retina. The light-sensitive cells on the retina sends electrical signal to the brain, which interpret the image as red.
We will use this eye model to simulate the formation of an image in the eye. The model contains a lens, an adjustable body, and a piece of tracing paper. The tracing paper simulates the retina. With a suitable length of the box, light from an object passing through the lens will focus on the tracing paper. Point the eye model at some faraway object. Adjust the length of the box to focus the object on the tracing paper. What does the image formed on the tracing paper look like? Cover half of the lens using a black piece of paper. Is there any change in the image?
Right. The image is brighter on the left since the lens is uncovered, and so more light can go into the eye model and then form a brighter image. But there's one big difference between the eye model and human eye. That is, the length of the eye model can be changed, while the human eye has a fixed image distance. 2. Focusing. A. The convex lens. A review of the lens formula. Both the cornea and the eye lens reflect light. Most refraction occurs at the cornea, while the eye lens is used for fine-tuning. We may use the lens formula to calculate the necessary focal length to bring the image of an object into focus, or simply to focus an object. The calculated F is the combined focal length of the cornea and the lens, or named it focal length of the eye. Nevertheless, the focal length of the cornea is fixed. Also note that the longest focal length of the eye is the lens to retina distance, when the eye focuses a distant object. B. Accommodation. Accommodation is the process of changing the focal length of the eye lens to focus objects at different distances. A healthy eye lens is elastic, while the shape and size of the eyeball are both fixed. The image distance is fixed, and so accommodation of human eye as well as other animal eye is by changing the shape of their eye lens. So, how to change the shape of the eye lens? Well, the lens is suspended. Yes, suspended. by ligaments named suspensory ligaments, like threads or fishing cord. Their tensions are controlled by the circular ciliary muscles. When the eye focuses a near object, the ring-shaped ciliary muscle contracts and it shortens. The suspensory ligaments get loosened, and so the lens restores its shape and bugles, forms a thicker lens with shorter focal length. On the other hand, when the eye focuses a distant object, the ciliary muscle relaxes and becomes longer and forms a larger ring. The ligaments become taut and therefore pulls the lens. Eventually, the lens becomes flattened and produces a longer focal length, and the lens becomes less converging. That explains why our eyes feel tired when we read for too long, as the ciliary muscles contract for too long. And it also explains why seeing distant objects after reading may relax our eye, especially the ciliary muscles. Example 1. Focal length of the eye. In all cases, the image distance must bear the lens to retina distance, which equals 2.5 cm. In part A, the object distance is infinity, and hence u equals infinity in the lens formula. And thus 1 over v equals 1 over f, and so the focal length of the lens equals lens to retina distance. In part B, the object distance is 25 cm, so u equals 25 while v equals 2.5, and hence f equals 2.27 cm, which is just a little bit shorter than the lens to retina distance. C. Near point and far point. For the normal eye of an average person, it can focus a distant object as well as a near object placed at 25 cm from the eye.
In this experiment, you can simply find the near points of your eyes using a pencil and a ruler. Firstly, take off your glasses if you wear any. Hold a pencil upright in front of your right eye at arm's length and keep your left eye shut. Focus on the tip of the pencil. You should be able to see it clearly. Now, move the pencil closer towards you until the pencil becomes blurred. This is the near point of your right eye. Ask your partner to measure the distance between the tip of the pencil and your eye. You may repeat the above steps for your left eye.
However, it is not uncommon that some people's eye cannot focus distant object or near object for various reasons. For example, when an eye lens is maximally thin, the distance of the object that produces a clear image is at the far point of the eye. For the healthy eye, the far point is at infinity. For short-sighted eye, the far point is closer than infinity. On the other hand, when an eye lens is maximally thick, the distance of the object that produces a clear image is at the near point of the eye. For the healthy eye, the near point is about 25 cm from the eye. For long-sighted eye, the near point is further than 25 cm. Do checkpoint 1 below.